Hello ECED3901. This is Lab 1 Part 1. This is your robot platform. So this has been designed by Dr. Vincent Sieben for this course, and it's a really nice platform. There's a custom PCB in the bottom here. We have a little mini PC, and in the back you can see the connections to the mini PC. And the top has this breadboard and your little LiDAR on the top, which will give you information on the course. So we're going to turn that on, see how it's operating in the lab, and connect to this mini PC. So normally there's these batteries that plug in, but if you don't want to use the batteries, which we're going to show you for the first little part, you can also plug in this power adapter. So check the lab written documentation for the exact power adapter. But to use this, what you'll have to do is unplug the power from the mini PC and plug in the power to the mini PC. So remember, this only powers on the mini PC. It does not power on the rest of the robot. So that's kind of the caveat with this thing. If you're plugging it in directly, you can plug a monitor into the HDMI port, or you can use the video capture adapter. So if you don't have a monitor, this is much easier because you just use your computer effectively as a monitor. So plug it into the second HDMI port there, and then plug the other end into a USB port. And what's going to happen, it's going to appear on your computer as a webcam. So you just open, on Windows the camera software, but any webcam software, and you will hopefully see the display. So now we can plug in our keyboard and mouse. So right after this, we're going to show you how you remotely connect to it. But this is good to know because you'll need to use a physical keyboard and mouse if you're recovering the PC, and sometimes if the wireless isn't connecting, this can be useful for troubleshooting. So there's two USB ports on the front. One's kind of blocked. So use one of the other ones on the back there. You just have to plug in. In this case, I have a separate keyboard and mouse. Follow the lab manual. You should have a little single dongle, so you don't actually need to worry about that. So I turn it on. You see the blue LED comes on. That means the mini PC is powered up. And after some time, so I've kind of quit here, we switch to the camera. We can switch camera inputs if needed. And remember, you've got to use the external mouse, so move the mouse around, and hopefully you'll see the cursor move in the camera. Don't get confused by your own cursor on your computer. You need to use the external keyboard and mouse. You should have a menu to the left. If you don't have a menu to the left, you might need to right-click and configure the display. So it should look like this. Notice how on the left side so this is Ubuntu. On the left side, there's a little menu with some dots and some applications and stuff like that. So if you don't have that, try right-clicking, hit display settings, and make sure your displays are set to mirror. And here I have 1920 by 1080 resolution. So hopefully you don't have to do that. But for the first part of the lab, we're going to open a terminal, and you can basically follow along the lab manual. And what that's going to do is you're going to turn on a basic ROS2 simulation. And so you have the commands in the lab manual. And again, if you have questions, go through the lab manual. I'm kind of giving you an overview so you can see what it should look like. Not all parts of the lab are going to have this. So then I've got to type on my external keyboard. Again, remember, we can't copy paste. We have to type on the external keyboard that command, the ROS2 launch ECED3901 lab5.launch.py, and press enter, and yay, we see the simulation start. So we see this running, and that's good. So basically at this point, we're happy. Things are running correctly. So we have a computer. The next thing we're going to do is we're going to instead connect remotely. So I'll press Control C in this window. Control C will kill that window. So this is on most OSs. We can press Control C to kill the window cleanly. We're then going to shut down, so you can use the sudo shutdown command. So again, this is all in the lab, or sudo power off, sorry. This is all in the lab manual, and just hit enter. And you can also use, up in the top here, there's a little, and see, I tried to use my computer mouse. It's easy to do. You can hit power off here, and that'll also shut down. So I'm just going to do it the way the lab manual says. And it should go like this, and then you'll see the blue LED turn off on the whatever it's called, little mini PC, and then we can plug the battery in. To plug the battery in, first we'll unplug our keyboard and mouse, or just if you got the one USB, just unplug the one. I'll also unplug the HDMI cable. We don't need that anymore. We're going to do this all wireless, which will be your normal sort of development setup. From here, you'll have to plug, and let's see if I can get some better light here, but you'll have to plug back in that DC power cable. So that power cable will connect the rest of the power to the mini PC power. So we'll plug that back in. And now we should be ready to go. So these batteries, you can check the charge on them. There's 3 little LEDs. There's a more accurate charge meter on the main, that little adapter PCB. So it just clicks in like that. You shouldn't have to force anything. And to remove it, so I'm trying to not block the computer. You basically, or block the camera. Press this red thing and then slide it out, so it's easier to do with the robot flat here. So you'll press that in and then slide it out, and it should just come out. Again, don't force anything. These are just little 3D printed adapters, and it should click in. So there's a toggle switch on the side here. Toggle that on, and what you should see is there's some LEDs that have the battery charge state there in the front. So you can see the green ones on the right are on, so it's fully charged. So when it gets down to like yellow, maybe switch the battery. You don't want to kill the computer, don't want to run out of power and kill the computer. So if I press the power button, the blue LED comes on. Now you need to give it time to boot, and after it's booted, then we can hopefully connect in to the computer remotely. While that's happening, grab your little stand. So there's a little rectangular box. Ooh, let's zoom in. There we go. Rectangular thing. Your robot should fit perfectly on that. We're going to be moving the motors. We don't want it to just run off the table. That's not going to be good. So yeah, check that out. So follow the guides. You may have to select this more options to put in the username and password, and then accept the certificate as I did there. You should get the terminal up again. So hopefully you just get this to work. It just comes up. There's some troubleshooting tips in the printed manual. What we're going to do now is we're going to actually look at running this robot. So we just ran a little simulation before. Now we're connecting remotely, so it's a lot easier to not worry about breaking our cables and things like that. So take a look at the lab manual that has the various commands to run. The first thing we have to do is actually get all the subsystems online, like the LiDAR and the motor controllers. So in the lab manual, there's this command I'll just paste in here. And we can use copy paste now that we are just with this remote PC. So when we run that, you should see the LiDAR start spinning. We see some blue LEDs flashing. This is all good. This is a good indicator that we have our system up and running. If this works, we can basically go ahead with the rest of it. So we will open new terminals, and then we're going to run additional commands. We want to keep that thing running. If you want, you can detach the terminals. So there I right-clicked and detached it. Sometimes you're going to be talking into terminals. Sometimes you just need the command to be running. So that like motor command, I just need to be running. So we're going to run this teleop twist keyboard command. I could copy paste it a little. We talked about Linux a bit. A little Linux hint here is that you can type the tab button. So if I hit the tab button on the side here, you can see it partially fills in, and if I press it again, it asks which of these two commands you want, and I can fill in the K and it fills in the rest. So that's really handy when you're using Linux. With this running, I can then drive the robot around, so we can move the motors forward, backwards, and you'll see the motor speed changing. And then on the side view here, the motor's spinning, so you can change the speed, try making it turn, and you'll see the motors moving in different directions. And you can follow the lab manual. You can take it off the platform and try actually driving it around to see how that works. But what we're going to go here is we're just going to jump ahead to the next part, and we're going to look at actually visualizing the LiDAR data and the state of the system. So I'm going to run the rvis2 command. This is going to be really useful for you in the second part of this lab, because you're going to be using this data. And basically pull this up. This is a point view of the LiDAR, and then put your hand in front of different places. You can move it around, and you can notice that LiDAR map changes. And you can put your hand in front, behind, figure out what's front, what's back. And you'll see, you can see some of these green dots moving as I move my hand, which blocks, you can see this line moving forward and back as I move forward and back. But also it blocks other things from being visible. The other interesting thing with this is that we can change what's the reference frame. So right now, if you go through the manual, you'll see they mention we changed this from base link, which is the base, the motor base, to the odom frame. So if you go to the bottom of this list, you'll see odom, which is the odometry. And the interesting thing is now, if I move the robot around, you'll see the robot itself moving. It's kind of keeping the map constant, and the robot is spinning. So we can see there's some movement still a little bit here and there. But we'll, talk about reference frames and things like that. But the point is that you can see now that the robot is trying to figure out where it is itself moving relative to everything else. So that's kind of the beginning part of the lab. The final part is you should try to figure out how you can view topics. So this is this ROS2 topic echo and topic info. It might take you a little bit to get used to these commands, but they're going to be really useful for the rest of your development if you're interacting with other sensors. You may want to talk to the IMU, talk to figure out what your orientation in space is and stuff like that. And so here I did the info command first. I think you actually want to do the echo command first. Typo on my part, but so the echo command gives us the data. The info command tells us what the data format is. So if I type echo, you can see the data for the LiDAR. It's coming in really fast. Hit Control C, and then you can scroll back and you can see information about it, like the ranges and intensities and things like that. To figure out what it is, I would get this info command, and I'd have this interface. And I'm going to guess it's not, no, I don't think it's this, but, okay. So we'll go back to the lab and we'll get the actual command. I'm trying to cheat here for this video. I think it's like an interface or interfaces command. Interface, okay. So we'll make it interface. Show, okay. So there we go. So this is the interface for that laser scanner, the LiDAR. So we can see, for example, there's a minimum range value in meters, and that the range data is in meters. And we need to, potentially filter out data that's above or below the valid minimums or maximums. So our minimum here is 0.1 meters. If we scroll up, we'll see this range min of 0.1 and a range max as well. So we also know that currently the LiDAR is only trustworthy between a certain minimum and maximum range. So you can play around with that. You can try putting your hand closer and further away from the LiDAR. and seeing if the LiDAR data will actually disappear. So that will be really important when we look at various sensors, as well as really important when it looks at doing sensor fusion. So the final thing is, again, we're going to shut it off using our power off command. Before we do that, we typically kill all of the terminals that are running with Control-C, and then close the terminals just in case there's any data they are supposed to save. And once we do that, we can then power off the robot. So I'm going to go back here. I'm going to close our Viz2. There's nothing to save that I care about. And I'm going to close that terminal, close this terminal, and Control-C this. And when I do this, we'll see some stuff shut down on the robot. So we can now do either our sudo power off command. If you can't access this for some reason, the other thing you can do is you can press the red button on the front, and it'll give you this. So it'll say power off in 60 seconds. So it takes 60 seconds, so don't shut off everything right away. But after we press that, we eventually will turn off. The blue LED goes off. We turn the switches off, and we're done.